You get a new nice symbol. Okay. So the way you read this is the intersection of A and B. Okay? And I'll just tell you now, intersection has this property that the order doesn't matter. What do you call that in arithmetic? The commutative property. Okay, so the intersection of A and B is the same as the intersection of B and A. Okay, we can say A intersect B or B intersect A. Okay, the intersection of A and B is the set of all the things that are in A and are in B, and nothing else. Okay, so you got to find the stuff that's common to the two sets. Okay, it's in A and in B. Okay, so if I take a set like this, A, B, C, and I intersect it with a set like G, D, C, F, what is the intersection going to have as members?
B and C.
A is here, but it's not here. B is here and here. C is here and here. F is here, but not here, so that's no good. G is only here, so it's this set. So you can see that the intersection is always going to have the same number or less, fewer members as the smaller set. If I have two sets, A is a subset of B, and I take A intersect B, what am I going to get? What?
All the members of A will be new sets.
Yeah, why?
Because since A is a subset of B, then all of the members of A has to be in B.
And nothing else is going to be in A, right? So A is a subset of B means everything in here is in here. So blah, 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 blah are here, blah, 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 blah are here. Maybe there's some other stuff, but all this stuff is in both. And I say, what's the intersection? The intersection is the stuff that's in both. So it's just going to be blah, 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 blah. Right? So if A is a subset of B, then the intersection of A and B is just A. Okay? It follows from that if we have any set like T, and we take the empty set, what's the intersection of the empty set with any set? What? John, I'm pointing to you. I don't looking around like that. What's the intersection of the empty set and another set? So we'll figure it out. The intersection is all the things that they both have in them, that are in both of them, rather. So what are all the things in the empty set? I'll give you an hour to list all the things that are in the set. How much time do you need? How much time do you need to list all the members? Nothing in there. There's nothing in there, so you don't need any time. So if we want all the things that are in here and are in here, I don't care what's in here. There's none in here, so there's nothing that's in both. So the intersection is that. Right? I mean, let's do it this way. There's the empty set, and let's say T is, I got A, B, C, D, Charles, Venus, Mars, and Earth, and universal love, and whatever. Okay? It doesn't matter. There's nothing in here. So the things that are in both at the same time is nothing. So the answer is the intersection of the empty set with anything is empty set. And what's the intersection of a set with itself? Is itself. Intersection, this gets kind of confusing. Intersection corresponds to the word and most of the time. Right? It says intersection is the stuff that's in here and in here. Okay? They're in both of them at the same time. The reason, here's why it's confusing. If you say something like this, okay, I hang out with Californians and flautists. Right? I hang out with people from California and with people who play the flute. That's not like intersection, right? That means if they're in the set of people from California, they can be my friend. And if they're in the set of flute players, they can be my friend. Right? So there, it's kind of like I'll hang out with you if you're from California or you play the flute, not and. But intersection means and in the sense of like, I hang out with people who are Californians and flautists. They have to be in both the Californian set and the flute playing set. And they're in the intersection of those two sets. Okay? So you'll see when we get to the next operation why it gets confusing. But intersection is supposed to correspond to and. You're in this set and you're in that set. Not or. Well, we already know that the intersection of the empty set with anything is the empty set, so the intersection with the empty set with the empty set is also going to be nothing. And we also know that the intersection of a set with itself is the same set. So if this was the empty set and this was the empty set, then that would be the empty set. So we have like 3 different ways of knowing that you're right. Yeah? Because if this is the empty set, if T is the empty set, it's intersect T with T is T. And the empty set intersected with the empty set is the empty set. That's one way. The other way is that the empty set intersected with anything is the empty set.
No, but like if A is A, B, C, and B is
Right, so A is the set that contains A, B, and C. And B is the set that contains what?
D, E, F.
D, E, F. Oh, okay, yeah, sorry.
The
Yeah, okay.
intersection of
Yeah,
D,
you were asking for something I didn't do yet. Good, good, good. Yeah, last 2 minutes, we got time. What's the intersection of these 2 sets? So this is it Tori?
Yeah.
Tori's question, I should have done this already, is that you can have 2 sets that have nothing in common. And then the intersection is the empty set. Or it's, look, I'm going to list all the things that are in both, and there's nothing to list. It's the empty set. So yes, so that's good. So Tori's question was a sophisticated way of asking, when you do this, you don't just give up and cry, you just say the answer is the empty set. They don't share anything. Okay? They don't share anything. Okay. So any other questions? Okay, so there's an overview of this in chapter 4. Also, you can go on Wikipedia and read the article. It's called Naive Set Theory, which doesn't mean set theory you can take advantage of or anything like that. So we have intersection, and we're ready for a new operation, right? So sometimes it's useful to just remind yourself that intersection is an operation where I take 2 sets and do something to them, and I get another set. Just like addition. You take 2 numbers, you add them, you get another number. Okay? That's different from the relationship between, X is a member of A, right? There we have an element and a set. And then kind of when you say X is an element of A, you can kind of think of it as it's either true or false, right? Either that's true or it's false. The intersection of A and B, it doesn't make sense to think about it in terms of true or false. The output of doing that is another set. So let's take something that's kind of like, similar to intersection in being an operation on 2 sets, A and B, and that's called a cup symbol sometimes, but this is pronounced the union. So the union of A and B. Okay? So the intersection of A and B was the set of things that are in A and in B. The union of A and B is the set of things that are maybe in A or maybe in B. Rather, they're in A or they're in B. But they got to be in at least one. And they could be in both. Okay, so let's do an example. So if this set is X and Y, and this set is P and X and Q and Y. Okay, what's the union of these 2? Well, yeah, so everything that's in one or the other or both, right? So P, X, Q, Y, X, and Y. Right? Is that true?
Yeah.
Is that the easiest way to write it? No. Because what do we know about sets? About how when we write their elements, what do we know? Repetition doesn't get you anywhere because it's just a matter of are you in or aren't you? So X is in there? Yeah. I could ask 100 times. The answer is the same. Y is in there? Yeah. So, and actually we just made a discovery probably. You can see that if A union B is equal to B, what's the case?
A is a subset of B.
Yeah. Because B contains everything in A. A's not bringing anything to the party, right? If we have them be different sets, like I don't know, R, then what's the union going to be now? RXY union PXQY.
RXY, P, and Q.
RXY, PQ, right? You just throw everything together into a bag, right? It's everything that's in A, or in B, or in both. Okay, so that's the union. Okay. Alright, so union and intersection have this property, I forget if we talked about this last time, of being commutative. Right, so the commutative property in arithmetic is, applies to addition and multiplication, right? 5 plus 3 equals 8. We can commute these two numbers, switch them around, 3 plus 5 equals 8. Same with multiplication, but not with subtraction, right? So 5 minus 3 is not the same as 3 minus 5. Okay? But union and intersection are both commutative. It doesn't matter. So if you say A union B, it's always going to be the B union A. Because all you're doing is saying, take everything that's in A, take everything that's in B, and put them together. It doesn't matter the order in which you do it.